All right. I don't know if anybody's excited or worried. I have no idea how to gauge you guys, but we'll find out. There. Okay. Okay, which one of you works? We'll find out. So, what I want to do, I want you guys to help me out with this. I'm going to draw the triangle that is definitely not a right triangle. Okay. Sometimes if I'm not careful, I draw a triangle that's a right triangle. Everybody agree this is so not a right triangle. That top angle is bigger than 90 degrees. The other two are smaller than 90 degrees. This is a valid triangle, poor little dude. Yes? I'm going to call, just because, it doesn't really matter. It doesn't matter. In fact, I should ask you guys, what do you want to call this angle? A, B, or C? C. What do you want to call this angle? Somebody else? A or B? You told me C. Who else? Oh, you said C. Oh, okay, sorry. I just knew it came from over that way. And then this one has to be B. I'll choose that one. So this will be side B, this will be side A, and this will be side C. Is everybody with me? Everybody understand it could have been any letters I put in those places. Does everybody know? In my other class where I'm teaching the same stuff, for some reason somebody really didn't make the connection that I thought I made pretty clear. If angle A is here, where does side A have to be? Across from it. You can't just put them wherever you want to, or else all these little things are going to go to shit. Side B has got to be across from stick B, and its mouth A has got to be across from stick A. Okay. If you don't do that, things are not going to work right, because that's what we're going to base this on. Now, trig, as we have it, will not directly relate to this. In order to develop a way for trig to work with this, we do, at the moment, still have to find right triangles, because at the moment, that's all it'll work for. You guys with me? Can anyone tell me what's the easiest way to kind of like cut this up so I make some right triangles? I like this. This guy back here is telling me, I don't know what this would mean, like a baseball thing. Steal second. Yeah, I'm sorry. So yeah, we can drop this down. Yes? Then I made two right triangles. Look at that. We're amazing. Somebody tell me, what do you want to call that line we just drew? I don't care. What do you want to call that line we just drew? Give it a letter. Give it a variable name. Because it will vary. I can make a different triangle. I don't care. Just as long as it's not A, B, or C. D? That's crazy. Sorry. Okay. We just got to give it a name, because if I would have made my triangle a little taller, it would have been different. It varies. It needs a variable. So listen, how many triangles did I just draw? No. How many right triangles did we just cut our triangle up into? Two. How many triangles did I draw? One. No, I drew an infinite number of triangles, because what could angle A be? Anything from 0 to 180. I need you guys to be really with me. Because we gave everything variables, they could all vary. You with me? Now, they can't violate big A plus big B plus big C is 180. You with me? But can't angle A, couldn't it really be like 1 degree, 1.3 degrees, 2.57934444441 degrees? I mean, so there's an infinite number of things. Okay. So what we're about to do will work, period. Because we're working with every triangle. I just had to give me one triangle to kind of have a visual anchor. Is everybody cool with what I'm saying? Sometimes I forget to say something like that. But when we derive a theorem, or in this case, this is going to be a law, so watch out. When we derive it, it works, period. Or I have to tell you when it works. So like the Pythagorean theorem only works for right triangles. We're going to extend the Pythagorean theorem so it works for every triangle. Even if you didn't want me to, I'm going to do it. We're not going to do that today. Too bad. Can somebody help me? In fact, let me just, in the interest of time, can somebody tell me if I write this, what triangle do I have to be talking about? Yeah, the one with sides B, D, and then part of C here, yes. Do you guys with me? Because right now, when I write a trig function, it's got to relate to a right triangle. Angle A is in that little right triangle on the left side. So what are you with me? So what is sine A from that triangle?
PD?
Say it, I'm sorry, Khadijah? D over B. Y over H, yes? Opposite over hypotenuse, whatever. Okay. And very quickly, just to say this, there really is nothing wrong with using SOHCAHTOA. As they say that, I don't believe it, but it will help with some triangles. The reason I try to get you to not use it is it becomes very quickly not useful. It helps with certain things, and it makes it feel so much easier, but then you're not going to do well later, especially in calculus, holy shit. So I need you to understand, I have reasons why I teach things a little differently than some other people do, because I'm thinking about what you're going to have to be able to do in the next class, for example, right? I'm not saying nobody else does, just saying SOHCAHTOA doesn't really extend. So can somebody help me solve this for D? Yes. Okay, so we got this one truth, yes? Now what if I said, what's the sign of B? Now I'm talking about that right triangle, yes? So I gotta talk about a right triangle to use sine, and the right triangle that has angle B in it is that one. So what is sine of B? What? What? D over A. Yes, D over A. Sine of B is the y side over the hypotenuse. Okay, let me stop for a minute. We haven't done anything earth-shaking. Everything we've done is old news. Where did I? There. No? Here, there. You're not going to believe what I'm going to ask you. What can I solve this for D? Okay. Do you all agree with me that D equals D in this triangle? In fact, everywhere in the universe. So if D is B sine A and D is A sine B, what must be true about these two things? Why did I make this a big A? Why did I make this a big A? Okay. So then B sine A equals A sine B. Okay. It's always weird for you guys when we're doing a derivation, because in the middle of it, it looks so not useful. We're almost to the end. We're not at the end yet. One more step. Wouldn't it be great if I could get all my A stuff together and all my B stuff together? So I'm going to divide by A, and I'm going to divide by B. So this will be like this, and that'll be like that. And then it really becomes powerful. So when is that true? When is that statement true? There's a whole reason I said what I said earlier. When is that statement true? For what kind of triangle?
For a right triangle.
No. Every single piece of this equation does it live in a right triangle? No, it lives in this original triangle. Was that original triangle right triangle? No, in fact, what triangles did I represent? Every triangle. So when is this true? All the damn time. If we go back and take any triangle we've ever done and we do this shit, it'll work. We just didn't need to because it was a right triangle and I could apply trig directly. Now listen, I could rotate this shit and do everything we just did but involve side C and angle C. And what I would end up getting is that this equals sine C over C. This might be the first time you've ever seen like a triple-sided equation, but this is not really an equation. It's a statement of equality, which is kind of different from the equation. This just says that whatever one of the ratios is, it's the same as the other ones. Now, real quick, this goes along with something I've said before. If I have a small mouth, an angle that has a small mouth, it's going to have a small stick in its mouth, yes? To make the mouth bigger, it's going to have a bigger stick in its mouth, correct? You guys with me? So look, if the mouth gets bigger, the stick gets bigger. So the ratio stays the same. If the mouth gets bigger, the stick gets bigger. So the ratio stays the same. Okay, guess what this is called? What's the only trig function in this statement? And what did I say earlier we were getting? It wasn't a theorem.
Oh, it's just a law.
It wasn't a process. Oh, this is the law of sines. Just in case you're curious. Right, okay. This is the law of sines. Okay. Enter the arena. Oh, I'm sorry.
Just out of curiosity, do more people use trigonometry for triangles that are not actually right triangles than
Do it again.
Just like more people use trigonometry for triangles that aren't actually right triangles.
More people. I'm not sure how to answer. Depends on what field you're in. But in general, yes.
Right? They just keep breaking them apart into right triangles.
It's easier to use this relation because you're not always guaranteed to have a right triangle. But here's the thing to remember. Will this work for right triangles? Yes, because it works for what kind of triangles? Oh, okay, cool. So I want to do a non-right triangle example of this, and then I want to do a right triangle example. And we'll do it two different ways, the old way and this way. And they better agree, or else we can all leave. Screw your math boy if it don't agree with itself. Okay, so somebody, let's see. Somebody give me, what's that angle, would you say? Give me a guess for what that angle is. Anything. Go. Not anything, but don't say 187.
35.
Say again?
35.
Kick ass. All right. Somebody else give me what this angle here might be. Don't say 90. It does look like it's probably more than 90. Do you see that? 100 degrees. I love it. So what does this angle have to be then if those two are 135? What's that last angle have to be? Yes, to make 180 total. Yes? Somebody cool? You guys cool? Okay. I'm going to give this one side length. I'm going to give us this side length here. This is 11 centimeters. Oh, that's right. No, we'll do that tomorrow. Okay. Tomorrow I'm going to bring some rulers and some protractors, and we're going to construct some triangles. Just in class, you never have to do it yourself. One of you guys looked very excited about that. How many guys have never used a protractor before? Have we all used protractors? Do you know how many guys, does anyone not know what a protractor is? It's something where it can measure angles. It's like a semicircle.
Oh.
And I'm going to lay it down and it can measure an angle.
Oh, I know what
We're gonna mess with it tomorrow. Just so I can make some of this shit concrete. Right, like that is a triangle, but if I actually construct a triangle and I do this shit, I might believe in it more. Okay. Now here's the law of cosines, Jeff. The law of sines. That's what we're going to do tomorrow. If you didn't know, there's a law of cosines. One thing I want to do is I label this. Otherwise, I don't know where to put stuff. So what do you guys want to call this angle 35 degrees? Which letter? A. Okay. What about 100 degrees? C. I love it. And then 45 would be B, which means this is little b, this is little a, and 11 is little c. Yes? You guys with me? So you want to identify this. Surely if you want to apply Pythagorean theorem, you want to identify the sides so you know where to plug them. Yes? So this is basically the same idea. Now here's a real clue about law of sines. I'm never going to use all three of these. So the idea is I could right now solve for side B if I just use those two. I could solve for side C if I just use those two. Yes? So you only ever use two at a time because I can't solve a triple-sided equation. Shit to do with it. But do you all see what's the most important ratio? The one involving what letters? Which ratio? Yeah. Why is C the most important? Yeah, so I think I covered the wrong things just a second ago. Because I can make a complete ratio. Yes, I know the angle C and I know side C. So. You guys tell me, which angle do you want, which side do you want to solve for? A? Okay, so I'm going to set up sine C over side C is equal to sine A over side A. And do you see how now I can solve for A? As long as you can make a complete ratio. You have an angle and its side, you can use law of sines. And what's going to be nice is, if I have a triangle that I've been given enough information for and law of sines doesn't work, law of cosines will. They kind of fill each other in. They complete each other. Yes?
That would mean that A would be 11 as well?
Hell no.
No.
Hell no. Sorry. Because does sine 100 equal sine 35?
No.
Hell no. So there's no reason the bottoms should equal each other. How do I solve this? Cross multiply. All right, do it. Oh, wait. Solve that. If you remember on your, oh yeah, you already knew this. I gave you that green sheet, yes? And this was on the upper right-hand corner, the law of sines and law of cosines? Okay. Oh, I've got calculators if you need one. Because these are not angles we know. So if I cross multiply, and then I divide, bless you. So don't forget, make sure you're in degrees and make sure you close the parentheses so you don't put too much stuff into each trig function, right? Let's see what I get. Are you guys playing along with me? No, okay. I get this. .41 centimeters. So like on a quiz or a test, I would tell you how much to round. If I don't say, normally like 2 or 3 places is good, but I will tell you. Why does it make sense so far? Why does it make sense that that side length is less than side C? Why does it make sense that this side is less than that side? Not even, because I could have drawn my picture horribly, yes? So don't just say because it looks shorter.
Because the degree is bigger.
Because the mouth of this one is bigger than the mouth of that one. This mouth is tinier than this. The stick in it should be shorter than, yes? Do you guys see? That's a great thing. Just when you do a problem, step back. Does it make sense? And I don't know how you feel about sticks in mouths. I'm sorry that you hate that. Make something else. But I love that. If I open this mouth bigger, a bigger stick fits in it. So that's perfect. It's how many, if we would have gotten 16, I made a damn mistake. Ain't no way that stick is that big in that poor little dude's mouth. Okay. Maybe. So then, here's the big mistake I see on this problem. Is everybody semi with me? You guys saw where this came from. You guys saw earlier where this came from. It's steps you could all do, it's just weird. They're not steps that would come to you, but people in the past that had more time than us sat there and played with it. So you all know that's true, that's valid, it works for every triangle. Here's the problem. What I always get is a few people will do this first step, and then they'll do Pythagorean theorem. Why can't I do that? Say again?
It's an approximate, so you can get
No,
It's not a right.
it's not a right triangle.
Oh.
When is the only time that Pythagorean theorem, as we know it, when's the only time it will work? It's a right triangle. And the whole purpose of this is it's not a right triangle.
What do you use?
Yeah, what do? How do I get that last side?
You find C and Z.
Yeah, you just do the same thing, except this time you put the B shit in. You put the B shit in. You put the B shit in. Okay, Jeff, whatever. So I make the same ratio I could from the beginning with the C's. I use this information one more time, but instead of setting up the A ratio, I'm going to set up the B ratio. I guess so. Sorry, you meant,
Yeah.
okay. Of course. Same work, yes? In fact, you guys could have picked this to do first. So who cares, whichever one you do first. Let's do the other one second. So now, if I kind of cut to the chase here, I would multiply the b up, multiply the 11 up, divide the sine 100 down. I would get 11 sine 45 divided by sine of 100. Since I'm so nifty, I would just go here and make that a 4. I just copied that and made it a 4. Woo-hoo. Does that make sense also? I'll make this about 7.9. What did I say? Centimeters? Does that make sense that this is 7.9? Not that it's 7.9, but that it is between these two links. Why does that make sense? That is between these two links, yes? So why does that make sense? Sorry.
45 degrees.
Yes, its mouth opens between these two mouths. So the stick in its mouth should be between the other two sticks. You guys see, the smallest angle should have the smallest stick. Biggest, the biggest, the middle, the middle. Woo! Okay, so you can always step back at the end of a problem like this and just say, does at least that make sense? It doesn't tell me that 7.9 is exactly right, but it does tell me that it makes sense. How do you guys feel about this? Normally, law of sines especially is almost a breath of fresh air. And I don't know if you guys are with me on that yet or not, but the equation is pretty straightforward. And then it's just plug and shove shit, yes? So here, let's see how you really feel about it. But, Okay. So here, let's do this first one together, and then we have to talk about the weird thing that could happen. So here's where you want to be a little nice to yourself, but you don't have to be precise. You don't have to go buy a protractor. When you draw this triangle, try to make C less than 90, more than 40. You know what I mean? Try to make it visually. It doesn't have to be perfect, but like I would put C maybe down here. So here's 90, so 77 is maybe like this. So there's C, yes? And then 41 degrees, there's 45, so maybe I go a little further out. There's 41 maybe. So that would be A. So this is side C, this is side A, this is B, and this is side B. Okay. Well, that ended up looking more like that. That doesn't matter. You don't even have to do what I just did. You can just sort of draw the same triangle every time, but it will visually make a little more sense if you're a little more careful about it. And that wasn't really that careful, so we'll see how that happens. Can I make, well, what's one thing I can get immediately?
Side C.
And by the way, the instructions would say solve the triangle. And what that always means is you have to end up knowing all three angles, all three sides. So whatever you don't know, you have to find a way to know it. So what is side of, what's the angle of B? What do I have so far in here?
62.
Yeah, I've got 118. So then 62 degrees more makes it
180.
180, yeah. Yes, right now. I was going to say, do we know a side? We know side A is 10.5, so can I make a complete ratio?
Yeah.
Whenever you can make a complete ratio, law of sines will work. If you can't, law of cosines will work. And that's assuming they gave us enough information. If they give me one angle, screw them. I don't know. Shit. They have to give me enough information. So what is the ratio I can make?
Sine 41 over 10.
Yes, sine of 41 degrees. Side, that's A divided by side A. And then again, it's the same as the last one we just did. I'm going to solve for B just because. By the way, if that comes up, that comes down, that goes up. Or you cross multiply and do one more step. It's up to you. And then you just plug all that in your calculator.
So when you do this, you want us to solve for all three sides, though, right?
Hell yeah.
Yeah. No.
Where'd it go? Sine 62 divided by sine 41. Kabam! So we get 14.13. I didn't give us any units here, but be careful if I do, I need them on there. Does that make sense so far? Yeah, because angle A is the smallest. Side B is across from a bigger angle. It should be bigger, and it is. And of course, side C, yes.
Did you do it with side C instead of side B?
Did I? Oh, what do you mean? Sorry.
Did you do the,
I have to. Is that, yeah, okay, let me catch up to what you're saying. We got side B, what do I still have to figure out? Side C. So I have to do everything for side C. Is that what you're asking? I don't know what you're asking. So we did everything with B, and we got side B. Now I want to do this ratio again. And now I want to relate it to C.
you also use
Oh, you're so, Miriam, okay, you're freaking me out. You're like reading my mind. You could totally make a ratio with B's now, correct? Two things. Could we have calculated little b wrong? Secondly, even if we did everything right, is this the exact answer?
No.
because you're rounded. So listen, if you did, I'm not going to take points off. But I always went back to what I knew from the beginning was right, because I could have made a mistake, and I rounded. So just to cover my ass, I want to try to get C right. I'm going to use the stuff I know for sure. Okay, good. And the same thing happens here. Cross multiply, but then I'll divide by this. So these two just change places. So I end up with C equals 10.5. Because that comes up, that comes up, that goes down. If you don't believe me, do all the cross multiplication work, and eventually you'll get here. And again, I can just go here. Sorry?
15.59.
Oh, you guys are telling me what it is. Go here, and I can change this to 77. Kabam! I like it. 15.59. Chippa-chippa. Do I have all three angles? Yes. Do I have all three sides? Yes, so I'm done. Now, do you notice on number 2, what do I say there?
Tricky.
Tricky. Okay. And that's not a reference to the 80 song. It's tricky to. I'm not going to suddenly start singing. I'm sorry that I did what I did. So I'm going to come do something I very rarely do. I'm going to draw on the board, because I think it works better up here, what I'm about to do. There you go. Okay. So I'm going to draw. So let me see. I'm going to give us some values. I want angle B to be, what do you got, Jeff? I don't know. Actually, let me do this less specifically for right now. Good point. Let's say I give us an angle. I drew the dotted line because I didn't give us how long that side is. I just gave us an angle. Let's say the angle I give us, all right, let's just call this B for right now. And then I give us side C. Are you guys all with me so far? Okay, I really want you with me. So I'm telling you specifications for how to create this triangle. I'm like, you're a construction company, and I want to make a little triangular plot in the back. And I'm the weird freaking dude, math boy that used to teach math that's gone a little senile, and I'm like, oh, I want a specific triangle. Yes. For some reason, I'm going to lean hard by Georgia Boy Roots when I get old. Yes.
So the lowercase, would that lowercase c, would that always represent the side length? Like, you know how you
All the lowercase letters are side lengths.
and the uppercase.
Uppercase letters are angles. And C sucks. Because lowercase c and uppercase C both look the same. So I'm sorry if that gets confusing, but hopefully. I try to make it really, like C really big
So
for the angle.
could you technically play around with B and A and just choose the angle for them as long as it's equal to 180?
How do you mean?
You know how it says the capital C is 18 degrees, right?
Sure.
So that would mean that we don't know what the angle of B or A is.
Go. Let me get there. I think you're just saying, can we just pretend pick numbers for A and B?
That's exactly what it is.
How many things could A and B be?
Infinite.
Sort of infinite, except they have to make these work too.
218. Oh. Okay.
So there's other constraints. Okay. But you got a really good point, which kind of leads into why this one's freaky. Okay. And I also tell us how long side B is. So let's say I'm going to draw it over here. In fact, here. In fact, don't look. All right. I got to make this a little shorter. I need to make something specific happen. Okay, right. Look. This is side B. Yes? This is my boomstick. This is side B. Is everybody with me? So side B. Shit, that's side B. Forgive the little knee in there. Okay. So I'm given, all right, so I, senile math boy, some of you guys are like, you're there, man, shut up. See, now I'm that boy. I'm old. I'm in my house, and I'm like, I want to make a little weird triangle in my backyard. I'm going to call up, hey, people. And I tell them, I need a certain length and a certain angle away from this side, but I'm not going to tell you how long that side is, but I want this one to be this long. Is everybody with me? I want to construct a triangle out of this. Now, where does this have to go? What side is it again? So where's it got to go? Across from B, yes? Okay, let me stop for a second. We know angle B. So we know how the rotation from this to this, yes? I don't know how long this side is. That's why I made it dotted. I don't know how long that side is. I know how long this side is. And it's got to be that angle away from the base, yes? So watch. This is so cool. Did I make a triangle? Yes! Did I make a triangle? Yes! So how many triangles can I make given the stuff I just gave us? 2. I can make 2 triangles. So there would be 2 entire answers for some of these problems. Exactly when will that happen, dear God, Jeff? Now listen, I'm going to tell you this. I'm not going to bring this back, especially if it's traumatic. Do you guys remember angle, side, angle? Side, angle, side? Now listen, I'm just going to mention it this one time. We're not going to get into side, angle, side proofs. You guys took geometry, yes? Do you guys remember those proofs? No? If not, I understand. You blocked it out. Is everybody with me so far? The concrete aspect of what we're doing. And everybody saw, you guys saw, the way I've got this, that's one triangle. Yes? In fact, let me draw it in. That is one valid triangle I can make. And here is the other valid triangle I can make. Yes? So given my specifications, they could create 2 triangles. Yes? And I don't care which one, because I only want the things I told them so they could pick. So from your aspect, I'm telling you this right now, if I remember correctly, number 2 should have 2 entire triangle answers, which is always exciting. Let me go one step further. What if, I want this, it'll be all right, Jeff. You can draw it again. All right. What if I had said I wanted side C to be this long? You ready? No, there can never be more than 2. Could I even make 1 triangle now? Can I make a triangle? Why can't I not? Doesn't it have to reach this side to make a triangle? So this poor little guy's like, are you guys understanding? I need you to remember this concrete thing we're doing, because the math, sometimes you're going to try to find 1 triangle, and the first thing you do is going to say, what's it say? Out of range? I got to remember what the error is. It's going to give you an error. And that's the calculator saying, you can't make a triangle. That's this. You can't make a triangle out of that, silly human. And if I make this exactly right, there's only 1 triangle I can make. That's only 1 triangle. If I swing it, it goes above this line. I could only make 1 triangle. So there could be 0 triangles. There could be 1 triangle. Or there could be 2 triangles. Yes? Okay. So what the shit does that mean for us mathematically? Okay, let's take a look. Does everybody understand the concrete nature of this? Now, real quick. The reason I brought up side, angle, side, and all that kind of shit, there was one that was called SSA, and that's the way they had to say it in high school, because most high schoolers can't handle. I can't handle markers. Thank you. Oh, thank you. This is the way we should call it. All right. Didn't I give us an angle? Yes. And then I gave the side next to it. Yes. And then I gave it the side next to that. Yes. So how do you remember the situation that could have 0, 1, or 2 answers? There you go. It's an ass. you guys are with me. Why did the first one not have that issue? Because it wasn't ASS. It was actually, I had all the angles, so this can't happen. Now, let me come back. Okay, let me bring this back. Where was it, Jeff? Yeah, there we go. So let me draw this back in. So here's one angle, triangle. And then here's the other one, this little sliver dude. You guys with me? So this would be angle C, or this could be angle C, and of course this is A up here. Do you see how this angle C is less than 90 degrees? I really need you guys with me. And this angle C is, that angle C is less than 90 degrees, yes? And that angle C is more than 90 degrees. Okay. Exactly what is the relationship? Let me stop for a moment. You saw how I created those two physically. I had the stupid markers put together, yes? Physically, I put those two triangles together. And now we're just saying, this triangle would have this kind of an angle C. This triangle would have this kind of an angle C, yes? What kind of a triangle is this? You could do it. What's true about the two side lengths, the dotted blue lines? They're equal. They were this, yes? They're both this. So what kind of triangle is that? Yes. In this triangle, let me call this C1 and this C2 just to make this a little easier to kind of keep track of. And let me use the marker that's actually works. That's C1, that's C2. What the hell is this? That's isosceles. Those sticks are the same size, so they're mouths. Doesn't have to be 45. Whatever this is, this has to be the same. Stay with me, stay with me. What is C1 plus C2? Don't overthink it. PO. No. Star Wars? We just had May the 4th, and now today is Revenge of the 6th. What kind of angle is this? Or how many degrees is here? 180. This is what weird-ass math people call a straight angle. We also call this a straight curve, because we're weird as shit. So what is C1 plus C2? 180. So what is C2? Okay. Now, this is not going to make... Now listen, just by itself, that hopefully makes sense to you, just by itself. As a student, I don't blame you for what does it mean for me, Jeff? What is my problem going to look like? Dear God. Yes? So let's take a look. Dear God. What time? Oh, good. I got just enough time to do this. Perfect.
It's kind of like the trigonometry identity of what the cosine or something.
Don't go anywhere. Let's just focus. Sorry, man. I only got so much time. Okay. So let's take a look at this problem. I'm going to give myself more room. You could do the same thing. I'm the king of not enough room. Let me turn my paper. Oh, where's my... There. All right, let's do this. So C is 18 degrees. Side C is 7. I'm just going to draw it like this for the moment. And side B is 10. So this will be angle B, this is angle C, this is angle A, this is side A. So there could be a second triangle like this. Yes? Do you guys see what I'm saying? Same idea. Okay. Can I make a complete ratio?
Yeah.
Yes, and what do I mean when I say that? Do I have an angle and its side? Because then it would make a complete ratio in my law of sines. What's a complete ratio mean? Angle and its side. So we can do this one, yes? So help me out. Sine of C over 7.
Equals.
What's the only other one? Can I do anything with A? Why not?
Because you don't have.
I don't know either one, but so I have to do B, yes? So this is different from the first one in a few different ways. I have different parts that were given to me. So I have to do B, which is kind of nice. I don't know what angle B is, but I know that side B is 10. Is everybody with me? I can construct those ratios really nice. I never want to do it so that I give myself too many variables in one equation, because then I can't solve that shit. That's why I didn't use the A's. How do I solve for B?
Cross multiply.
Big B. All right, good first step. I watch this. I'm not going to cross multiply, because how do I solve for sine B?
You just
Multiply by 10. Die. So I get sine B is 10 sine of 18 degrees. Good Lord. All over 7. How do I solve for angle B now? How do I kill the sine? Divide by sin? Your sins away. No. Inverse sine. Beautiful. I gotta kill the sine. The only thing that has that ability is inverse sine. I take the inverse sine of this side, and I take the inverse sine of this side. Try to plug that in your calculator if you have one. Make sure you're in degrees. You should be in degrees. Notice we're basically going to do these kind of problems with degrees, because radians would just make it look worse. And they're triangles, so degrees make sense to use. In that they're specifically triangles, so we might as well use degrees. So try to plug that in your calculator and see what we get. Be really careful. I hate this about this dumb calculator. Be really careful that if it opens a parenthesis for you, you close it, or else everything you write after that is inside of that sign. It's sort of like Microsoft Word when it tries to guess what you're trying to do, and I'm like, I know what I'm doing. Stop changing shit.
0.44.
I don't know. Are you in degrees?
I don't know. I just plugged
You're in
it.
radians, yeah. Okay. So 26.2 basically. Is that what you guys got? So I'm going to call this B1, because that's the angle that goes with this triangle. But don't we have a potential second triangle? Okay, I really want you guys, I always do this, I always want you to go with me. So does one triangle at least exist? Yes. If there would have been no triangles, we would have gotten error here. In fact, let me try to force that error to show up just so I remember what it is. Give me a second. Give me a second. Oh, that works still. Holy shit. Here, that won't work. Haha. Okay. I just made a different number. So if you do this and you get that, either you plug something in wrong, or no triangle exists. That would be where this poor dude was too long and the other guy was just dangling, right? So geometrically, physically, that's what it means. The calculator, it can only tell so much. It just says, hey man, you're working with stuff that ain't gonna work. This is what it tells me. Okay, so some answers will be no solution. When that happens, you're like, yay. So how the shit, Jeff? How the shit do I check if there is a second triangle?
Cut in half.
No. What did we say earlier that this here was? How is it related to
Oh, it's
this?
equal.
No. This is the same. This would be the actual angle B in the other triangle, yes? So what is this? 180 minus that. Can somebody do that for me? What is 180 minus 126.2?
Looks like yours.
Sorry. 153.8, yes? Okay. Well, you know, I want people to feel like they're control.
Oh, so that's
Now,
what you
no.
mean.
Wait one second. Here's, because there could be just one answer. So how do I know there's two answers here? What angle lives in the triangle already? What angle lives in the triangle no matter what? 18 degrees. If I put this one in there, is there room for a third one? So for example, if we would have gotten 170 here, what's 170 plus 18?
198.
170 plus 18 is 188? Could that happen? No. 153 plus 18 is what? 170.
171.
Does that leave room for a third angle?
Yeah.
In fact, I know the third angle would be 9 degrees in that case. You guys follow? Okay. Whenever I have an ass situation, which is a hilarious phrase for me to say, whenever I have a triangle where I'm given angle, side, side, when I find my first angle, I must do 180 minus that and see if it works with the other angle that's already there. If this was 170, there would be one answer. This is 153. It works because when I add it to the angle I already know, there's room left over for the third angle. So there are two triangle answers for this. It does do that swing over thing that we did up here. So I'm not going to worry about this. I'm going to focus on finishing the first one. And then I'm going to go back and I'm going to finish the second one. I'm going to do all the same work. So, ignore that he exists for the moment. Right? He can be sad for a second. We'll get to you. Shut up. If B is this and C is that, what's A? So now we're going to put that here. So what is A then? Don't overthink it.
9.
If I got two angles, no. That's for the other guy. We're doing this one.
Oh.
If B is 26.2 and C is 18, what's A? How'd you do that?
180 subtracted.
Yeah. Add what I got, subtract it from 180 to see what's left over, right? So yeah, you'll get 44.2. Which, like you said, is 135.8. Yes. Does everybody understand how we got that? So, in the first triangle, B would be 26.2. C is 18. All three angles together have to add to B. So if I just do 180 minus what the other two angles are, I see what the third angle is. So don't make more out of that. That part by itself is simple, thank God. What's the only thing we don't know now for this big triangle? Yeah, because now, well, we know side of angle, we know side C, we know side B. The only thing we don't know, side A. So how do I get side A? Can I make a complete ratio now? Yes, because now I know angle A. And now we're going to have to use this approximation, but we're going to be okay. So if I set up the stuff that we used earlier for C, that's the one we knew from the beginning, and now I set up the stuff for A, I can solve for side A. Oh, this is almost perfectly timed. So just to cut to the chase, the 7 would come up, the sine 18 would go down. The same math always happens, so we're just going to do that. If that's magic to you, just do the work. And then, no, get out of the error. Stop it. 7 times sine of 135.8 divided by sine of 18, and I get 15.793. I didn't give us any units, did I? No, I suck. And we're going to put A1 here, because this is all about triangle 1. So why does it make sense that side A1 is so big compared to the other two sides? Bless you. Why side A1 being so big makes sense? Because in this triangle, angle A is huge. Now, real quick. All right. I still got 2 minutes. That's one triangle done. Now, come to the other triangle and you do everything the same. You do all the same steps, but now B is this. So what will angle A2 be? We said it roughly earlier. 9.2, yes? Wait, 8.2? Yeah, what was this? This was, oh yeah, 8.2 degrees. So 153 plus 18. Subtract that from 180 to see what's left for the last angle. And by the way, look, do you agree this angle is big?
Yeah.
If I swing this over, now what's angle A? It's very small. Big for the big triangle, small for the little silver triangle. Do you guys see? Do you guys see? Okay. How do I get side A? Same shit as before, except now instead of this angle, I'm going to put that angle. It's kind of silly. I have double the work, but it's the same steps for the second triangle. So A is equal to 7 sine of 8.2, and if you're smart, you can go back to your calculator, and you can just hit second enter, and you can make 135.8 become 8.2. Shabam! And this time I get, why does it make sense that it's so small now? Because now in the second triangle, angle A is the smallest angle, so it should have the smallest side. Crazy shit. So, tomorrow we'll do law of cosines. It's going to take Pythagorean theorem and just tack at the end a little adjustment if it's not a right triangle. Oh, I forgot. Maybe I'll do, I want to make sure you guys see that this still works even if it's a right triangle. I'll do that first thing tomorrow. Okay. I'll see y'all then.